This video is going to be on solving by graphing. So looking at our first example, we have two linear equations, y equals x plus 2 and y equals 3x minus 2. Okay, so we're going to start by graphing them. I'm going to graph this first equation in pink, and I'll switch colors for the second equation. So what we need to do is know that this is in y equals mx plus b. Remember, we always start with our y-intercept, which is that b value. Our y-intercept is always plotted on the y-axis. This is our x-axis. So looking at this first equation, positive 2 is my y-intercept. So I go on the y-axis, I go to positive 2, I put a point. Okay, now I need to know what my slope is. Well, there's a number 1 in front of this x, so it's 1 over 1, which means I go up 1 positive direction, over the right 1 positive direction. And I keep following that pattern. Up 1, over 1, up 1, over 1. I could also go down 1 and then negative direction 1 because two negatives make a positive. And then I connect the points and I make a line. Looking at the second equation, I'm going to graph this one in blue. Again, my y-intercept is negative 2, so I'm going to go down 2. My slope is 3 over 1, which means I can go up 3 and over 1. So I go up 3 over 1, up 3 over 1, up 3 over 1. I could also go down in the negative direction 3, and then over in the negative direction 1. Again, two negatives make a positive. I connect the dots. What I'm looking for is the place where the two lines intersect. So if I notice, they intersect right here. That is my solution. That is what I'm looking for. So the solution to this would be 2, 4. Moving on to the second one. Notice this one is different. It is not solved for us in slope-intercept form, so we have to solve for it first. So down here, I'm going to solve the first equation for y to put it into slope-intercept form. So I subtract 3x from both sides. The 3x's over here cancel out. I'm left with 4y equals a negative 3x plus 4. I divide everything by 4. I get y equals a negative 3/4 x, leave it as a fraction, plus 4 divided by 4 is 1. So I'm going to graph this. My y-intercept is 1. I plot it at 1. My slope tells me I go down in the negative direction 3 and over in the positive direction 4. One of the numbers has to be negative in order to make the whole fraction negative. If you do both of them negative, you're going to end up with a positive slope. So I'm going to go down 3 over 4. Down 3 over 4. Okay. I could also go up 3, but to make it a negative slope, I have to go over in the negative direction 4 and put a point. Up 3 over 4. Okay. You only need as many points until you see if the lines intersect. So you don't have to do 5 points every single time. You need at least a minimum of 2. So there's my first line. Okay, my second line, I need to solve for y. I need to put it in slope-intercept form. Okay, so again, I'm going to move over that x term by subtracting. I have 4y equals a negative 3x minus 16. I divide by 4. So I get y equals, leave it as a fraction, negative 3 over 4x minus 4. Okay, so my y-intercept on this one is negative 4, so I go down 4. And my slope is a negative 3 over 4. So again, I go down 3 over 4, down 3 over 4. I could also go up 3 and then in the positive or negative direction 4. So up 3, negative direction 4. So looking at these two lines, I noticed that they are parallel. And we know that parallel lines never intersect. I also could have told you that they were parallel is because they have the same slope right here. When we have two parallel lines, that means there is no solution because the two lines will never intersect. So that would be my answer, no solution. The last example I have, we have a negative 7x minus y equals 3. And an x minus y equals a negative 3. Again, I need to solve and put these in slope-intercept form, so I'm solving for y. So I'm going to solve this first equation. Okay, I need to move this x term over, so I do the opposite and I subtract. This is where we have to be careful because I'm left with a negative y equals a negative 7x plus 3. I have not yet solved for y. I have solved for negative y. So to get rid of that negative, I need to divide by a negative 1. So I get y equals a positive 7x minus 3. So my y-intercept is negative 3. I start at negative 3 on my y-axis. So here's my y-axis. I go down from the origin 3, 1, 2, 3. My slope is 7 over 1. Which means I go in the positive direction 7 and over 1. Okay. I don't think I have room to do any other points, but we can see. So I can also go down 7. 1, 2, 3, 4, 5, 6, 7. And in the negative direction 1. Remember, two negatives make a positive, so I still have a positive slope. So I connect my 3 points to the best of my ability. And I get that. Now I need to solve my second equation for y. Okay, so I have x minus y equals a negative 3. Again, I'm going to move over my x term. My x's cancel out. I'm left with a negative y. Don't forget that negative. And I have to divide by a negative 1 to solve for y. So I get y equals x plus 3. So on this one, my y-intercept is positive 3, so I go up 3. And my slope is 1 over 1. So I go up 1 over 1, up 1 over 1. I could also go down 1, negative direction 1. Two negatives make a positive. But I only need enough points to see where the two lines intersect. And looking at this one, they intersect right here. So I just need to determine that point. So it is 1, 4. So my solution to this would be 1, 4. So this is a video for solving systems by graphing. I also sent out the notes if you need to write them down as well.